Are you able to guess why they would tell us that we have segment AC? I don't think they, or excuse me, line AC. I don't think they really had to tell me that we have line AC, but they're trying to point something out. What does that mean about a couple angles here, like angle ABD and DBC? Well, it means they form a line, just to make sure that we're thinking of that. So if something forms a line, what kind of conclusion can we make? So if we just have that, even if we just had that picture, this is one of those things where they don't have to even tell us. We should know if they form a line in the picture, we can say something else. So find on your sheet, or pause if you need to, go look. Where do we have a theorem or definition that starts off with knowing two angles form a line? And if you're ready or know, I'll go ahead and write it in now. Supplement theorem. If not, maybe go look at the supplement theorem, pause and see what does the supplement theorem say. Well, it starts off knowing that two angles form a linear pair and allows us to say that those two angles, in this case angle ABD and angle DBC, are supplementary. That's the conclusion that the supplement theorem makes. The law of detachment, if you know it satisfies the conditions, go ahead and make the conclusion. So that line is there, those two angles satisfy the conditions for the supplement theorem, we'll make the conclusion in the supplement theorem that they're supplementary. Well, that didn't get in this equation, but that will lead to something else. If I know they're supplementary, what does it mean to be supplementary? Definition of supplementary angles. Go look on your sheet and see what type of conclusion are we making when angles are supplementary. We're allowed to say, just by what it means, just by definition, that those measures will total, they'll add up to 180 degrees. First we can say they're supplementary, now we can say they're 180 degrees, and have a second equation. If we need to get something else from the picture, we'll go back and look, but once you get that second or that third equation, start seeing how things fit together. And see if you can't look ahead to what you're trying to prove and see if that makes sense, that will get you where you want to go. So what can we replace? How can we fit these together? We did something very similar in 11. Just substitute. If we knew x was 2, we'd plug in 2. We know this angle is 120, plug in 120. Substituting, replacing, it's just different words for the same thing. So we're going to plug in 120 degrees in for measure of angle ABD. That's substitution or replacement rule. And now how do I know that DBC is going to equal 60 degrees? Well, it has to make it sense, but in a formal proof you need to show that and justify that. We're going to subtract the 120 from both sides. You don't have to show that. It's some algebra again. But if it helps for you to see it there, you can put the minus 120. Again, the arithmetic you don't have to show, just show me what you're going to get and say, what did you do? Subtracted from both sides. Go look for that property again if you don't remember. What says you can add or subtract something from both sides of an equation? Additive property of equality. That's actually our final statement. I'll put my symbol for therefore, my 3 dots. Therefore, we know that the measure of angle DBC is equal to 60. One thing leads to the next.